Okay, this video is the last in a three-part series on the method of undetermined coefficients. In the first video, we introduced the idea of the method of undetermined coefficients, and we set up the principles on which it is based, and then started doing some examples. And then in part 2, we continued with more examples. And then in that video, we also gave the viewer the opportunity to try these examples here, just to see if they are, understanding the ideas. So if you are watching this and you haven't gone through part 1 and part 2, we strongly advise that you do that first. And if you're going through this and you haven't done these examples, again, we strongly advise that this video is going to be most helpful if you have actually tried these examples yourself. All right, so we're now going to have a go at G. So G says y prime minus 2y is equal to sine x, and then there is an initial condition when x equals to 0, y is equal to 2. Incidentally, we have done this same problem in a video entitled linear first order equations, because it is a first order. So if you want to check the approach that was done there for linear first order linear ODEs, so if you want to check the approach that was done there, then that is going to be very instructional. All right, in this case, so the associated homogeneous equation is going to be y prime minus 2y equal to 0. This is the associated homogeneous equation. The auxiliary equation for this is going to be r minus 2 equal to 0, which is giving us r equals to 2. So this tells us that the complementary solution is going to be k1 e to the 2x. So that is the complementary solution. And then we're going to seek a particular integral of the form. So looking at the nonlinear term here, it's sine x. So that suggests that our yp is going to be a cosine x plus b sine x. The ODE has got a first order derivative, so differentiate this once gives us b cosine x minus a sine x. Then we are going to substitute into the ODE. So the ODE is y prime minus 2y equals sine x. So we are going to get b cosine x minus a sine x, which is y prime, then minus 2 times a cosine x plus b sine x. And then the right hand side, of course, is sine x. Collecting terms aside, we're going to have b minus 2x into 2a into cosine x, and then minus a plus 2b times sine x. Then comparing coefficients of sine and cosine, on the left hand side, coefficient of cosine is b minus 2a. On the right hand side, coefficient of cosine is 0. Then on the left hand side, coefficient of sine is minus a minus 2b, and on the right hand side, the coefficient of sine is 1. Solving these is going to give us minus 1 over 5 as a, and b is minus 2 over 5. Right, so that means our yp is going to be equal to negative 1 over 5 cosine x plus 2 sine x, and the general solution, which is yc plus yp, so that one is going to be k1e to the 2x minus 1 on 5 cosine x plus 2 sine x. Then at this point we're going to apply the initial condition. So given that when x is 0, y equals to 2, so that means we're going to plug in y equals to 2 this side, and on the right hand side we're going to plug in x is equal to 0. So we're going to have 2 is equal to k1 minus 1 over 5, because the sine 0 is 0. So this tells us that k1 is going to be 11 over 5, and hence our particular solution is going to be 11 over 5e to the 2x minus 1 over 5 cosine x plus 2 sine x. If we factor out the 1 on 5, then we can write this thing as 1 on 5 into 11e to the 2x minus cosine x minus 2 sine x. And so that is going to be our final solution. Then our next problem is h. So in h we have y double prime plus 2y prime plus y equal to 4 times e to the minus x. The associated homogeneous equation is going to be y double prime plus 2y prime plus y equal to 0. Its auxiliary equation is going to be r squared plus 2r plus 1 equal to 0. This factorizes to r plus 1 all squared. So that means we've got a double root, r is negative 1. So therefore the complementary solution is going to be k1 plus k2x e to the minus x. Just going to remove the brackets here for reasons that you will see in a moment. K2xe to the minus x. Then we're going to seek a particular integral of the form. So based on the nonlinear term is e to constant times e to the minus x. So we want to yp to take the same functional form. This is going to be ae to the minus x. Now, so at this point we need to compare this with the terms of yc. And we can see that this term is exactly the same form as the first term of yc. So that means that is not going to work. So we need to multiply through by x. Multiply through by x, we're going to have axe to the minus x. And then again, comparing with the terms in yc, this is exactly the same form as the second term, constant times x times e to the minus x. So that means that is not going to work as well. We multiply by x one more time. Then we're going to have ax squared e to the minus x. Now this term is not similar to any of these terms here, so that means that is going to be the form of our yp that we're going to proceed with. Then if we differentiate this using the product rule, when we differentiate x squared, we get 2x. When we differentiate e, we get to multiply everything by -1. If we differentiate this again, then we find a into 2 minus, it's going to be 4x plus x squared. Again, just make sure that you can fit in those steps in between. Then we're going to substitute into the ODE. So remember, ODE is y double prime plus 2y prime plus y for e to the minus x. So y double prime is a into 2 minus 4x plus x squared. Then 2 times this one is going to be 2a, 2x minus x squared, and then yp is just ax squared. So everything here is multiplied by e to the minus x. And then on the right hand side we've got 4 times e to the minus x. Okay, let's remove the brackets on the right hand side. Then we're going to have 2a minus 4ax plus ax squared. In fact, we don't need to work with the a because the a is a common term, common factor as well. So this is just going to be 2 minus 4x plus x squared. Then it's going to be plus 4x minus 2x squared and then plus x squared ae to the minus x, and that is the term on the right hand side. Then so when you collect terms, the 4x and the minus 4x cancels out. The x squared terms cancel out as well, because you have got 1 here plus another 1 and then minus 2 of them. So that means on the left hand side we just have 2ae to the minus x equals to 4e to the minus x. So this is telling us that a is simply equal to 2, and hence yp is 2x squared e to the minus x. So remember, it's got an x squared term because that was the last form that we found is going to work. And so yg is going to be yc plus yp, and so we're going to have k1 e to the minus x, k2 x e to the minus x plus 2x squared e to the minus x. And so we can factorize this. Is going to be k1 plus k2x plus 2x squared e to the minus x. Right, then we have got 3 more to go. The next one is example number I. So in example number I, we have got 4x squared y double prime plus 4xy prime minus y equals to x squared. The associated homogeneous equation is going to be 4x squared y double prime plus 4xy prime minus y equals to 0. This is an Euler's ODE. We do have a video on this, and the way we solve it is we seek a solution. It's going to be our yc x to the power m. Then derivative of this is going to be mx to the power m minus 1. Second order derivative is going to be m into m minus 1 x to the power m minus 2. Then if we take this and substitute it here, all the x's are going to be to the same power, which is just m. So we're going to have 4m into m minus 1 plus 4m minus 1 x to the power m equal to 0. But then x to the power m cannot be equal to 0. And this thing simplifies to 4m squared minus 1 equal to 0. Because we're going to have minus 4m here plus 4m there. So that tells us that m is either plus or minus 1/2. And so our complementary solution is going to be k1 square root x plus k2 over square root x. Then we're going to seek a particular integral based on the term on the right hand side. We've got a quadratic here, so we're going to look for yp, which is a general quadratic expression. So the derivative of this is going to be b plus 2cx, and the second order derivative is going to be 2c. Then if we plug into the ODE, I'm just going to skip some steps. Plug into the ODE and collect terms. We are going to have 8c plus 8c minus c. These will be the x squared terms. Then the x terms will be 4b minus b times x. Then minus a is equals to x squared. Then comparing, you can see that on the right hand side there is no constant, so that tells us that a is going to be equal to 0. And then on the right hand side again there is no x term, so that tells us that b is going to be 0. And then so we're going to have 8 plus 8 is 16 minus 1 is 15, so c is going to be 1 over 15. So the general solution yc plus yp is going to be k1 square root x plus k2 over square root x plus x squared over 15. Okay, so that was example number I. We're now going to go to J. In J we have got y double prime minus 4y is equals to 4xe to the 2x. I'm going to jump straight to the complementary solution. Or maybe just quickly, the auxiliary equation of the complementary associated ODE is going to be this one, which gives us plus or minus 2. So that means yc is going to be k1 e to the 2x plus k2 e to the minus 2x. Then for the particular integral yp, we're going to look for a solution guided by the form of the non-homogeneous term. So that we've got a linear polynomial times e to the 2x. So we're going to look for a solution of the form ax plus b, which is a general linear polynomial with undetermined coefficients a and b, and then times e to the 2x. Now comparing this with the complementary solution, we see that the b times e to the 2x is of the same form as the k1 times e to the 2x. So that means the second term here is going to be a problem. So we need to multiply everything by x. So we're going to have ax squared plus bx e to the 2x. Okay. Then we are going to have to differentiate this. So yp prime, I'm just going to go straight to the final expression. So it's going to be 2ax squared plus 2 into a plus b x and then plus b all times e to the 2x. Then the second order derivative term similarly is going to be 4ax squared plus 8a plus 4bx plus 2a plus 4b all times e to the 2x. Now the ODE is y double prime minus 4 times y. So we need to multiply this by 4. So I'm going to multiply it by 4 and write it here under the y double prime. So there's going to be 4ax squared, and then there's going to be 4bx e to the 2x. So what this means is that yp double prime minus 4yp is going to be such that this term cancels out and this term cancels out. So we're just going to have 8ax plus 2a plus 4b e to the 2x. This is equal to 4x e to the 2x on the right hand side. And then when we compare the coefficients, so the x term and the x term must match. So that tells us that a must be equal to 1/2. Then this term must be equal to 0 because we don't have such a term this side. So plugging in a equals to 1/2 in, so the equation is going to be 2a plus 4b equal to 0. This tells us that b must be equal to -1/4. And so the general solution, which is yc plus yp. So remember, yc is k1 e to the 2x plus k2 e to the minus 2x. And then for yc, we just have found that a is 1/2, b is 1/4. So we just go a is 1/2 here, b is -1/4. So that's going to be x squared over 2 minus x over 4 e to the 2x. We can either leave it like this, or we can combine these two terms and factorize. Okay, our last problem here is actually just looking for this j. So our last problem is k. So k has got y double prime plus 4y equal to 8x squared plus 8 cosine 2x. The associated homogeneous problem is y double prime plus 4 equal to 0. The auxiliary equation of it is r squared plus 4 equal to 0. So we've got r equal to plus or minus 2i. So the complementary solution is going to be k1 cosine 2x plus k2 sine 2x. Then the form of the particular integral yp. So we've got a quadratic here. So for that, we're going to have to write a plus bx plus cx squared. And then we have got a cosine 8 cosine 2x. So for that, we're going to have to write d cosine 2x plus e sine 2x. So that's just based on the non-homogeneous term. So because we have got the sum of a quadratic and a trigonometric term. So this term is the functional form of the quadratic, and this one is the trigonometric term. Now, comparing now this with yc, we see that these last two terms are exactly the same form as yc. So that means we're going to have to multiply these ones by x, just this term, not this one, because there is nothing here which is similar to that. So that means we're going to have to modify our yp. This one is not going to work. So we're going to have to multiply our yp into a plus bx cx squared. Then everything here is multiplied by x. All right. Then we need to differentiate this twice. The first order derivative is going to be b plus 2cx, then plus d cosine 2x e sine 2x. We're just differentiating the x plus by the product rule. And then when we differentiate the terms inside now, we're going to have e cosine 2x minus d sine 2x. We need to tidy that up. So we're going to have b plus 2cx. The cosine term is going to be d plus, there is going to be a 2 factor of 2 with each of these. So 2x there. So that is going to be d plus 2ex cosine 2x. And then the other term is going to be plus e minus 2 dx sine 2x. So that's going to be yp prime. Then yp double prime, just going to go straight to the final expression here. It's going to be c plus 4e minus 4 dx. So this is the cosine term. Okay, then minus 4d plus 4ex. This is the sine term. Now remember, we need to multiply. Need to add these to 4 times yp. So I'm just going to write 4 times yp here. 4yp is going to be, so we're going to multiply this by 4. So 4a plus 4bx 4cx squared. Then multiply this term by 4, which is going to be 16e minus 16 dx No, I'm multiplying the wrong thing. It's this that I should be multiplying. So I need to multiply this by 4. So it's got to be 4 x d cosine 4 dx cosine 2x plus 4ex sine 2x. Right. Then we need to add these two. So yp double prime plus 4yp is going to be 4a plus 2c. So that's just this term and this term. Then it's going to be 4bx, which is this term. Then we're going to have 4c x squared, which is this term. Then let's start with the cosine terms. We've got 4dx here, cosine 2x, and we have got the negative of the same there. So we're just going to have 4e cosine 2x, 4e cosine 2x, and then the sine terms, we have got 4ex here, negative 4ex here, so we're just going to have negative 4d sine 2x, negative 4d sine 2x. And then of course on the right hand side we have got 8x squared plus 8 cosine 2x. Alright, and then the constants we can now determine by comparing the coefficients on the two sides. Let's start with the x squared terms. So comparing coefficients. So if we compare the x squared terms, on the left hand side we've got 4c as the coefficient of x squared. On the right hand side we've got 8. So this tells us that 4c must be equal to 8, and so c is equal to 2. Then we're going to go to the x terms. There is only one x term this side, which is 4bx. This side there is no x term, so it means b must be equal to 0. b is equal to 0. And then the constants on the left hand side, we have got 4a plus 2c. C we already know is 2, so 4a plus 2c is the same as 4a plus 4. On the right hand side there is no constant, so this must be equal to 0. This is telling us that a must be negative 1. Then we go to the sine and cosine terms. On the left hand side, coefficient of cosine is 4e. On the right hand side is 8, so 4e must be equal to 8, so e must be equal to 2. And then sine 2x term, on the left hand side we've got negative 4d as the coefficient of it, negative 4d. On the right hand side there is no sign, so this tells us that d must be equal to 0. And then we can plug these into our yp. So this is actually telling us that yp must be equal to, so if you just go back to the original expression of our yp here, Okay, so a is -1, b is 0, and c is 2, so it's going to be 2x squared minus 1. So got 2x squared minus 1. D is 0, e is 2. So we're going to have plus 2x sine 2x. So D is the coefficient of cosine, E is the coefficient of sine. So that is our YP. And so the general solution, YG, is going to be YC plus YP. So this is going to be equal to K1 cosine 2x plus K2 plus 2x sine 2x, then plus 2x squared minus 1. So that is going to be our general solution. All right, thank you for watching this. Hopefully it has been useful. Please do subscribe at the bottom there, so that you can get notified whenever we post new material. Thank you very much.